Hello guys, welcome to Apex Math. My name is Pino. In this video, we go through question 5 from the August 2023 N5 Mathematics question paper. Question 5.1, we integrate x multiplied by e raised to the power negative 2x, and our integral is from 0 to infinity. We have a product of two functions, the x and the e raised to the power negative 2x, and we can use the u substitution method, so we are going to use integration by parts. And the formula available in the formula sheet is the integral of f of x multiplied by the derivative of g, the g prime of x, dx, which is equal f of x multiplied by g of x minus the integral of g of x multiplied by the derivative of f of x, the f prime of x, dx. This part of the formula for integration by parts is equal to the x multiplied by e raised to the power negative 2x. Between the x and the e raised to the power negative 2x, we determine which one will be equal the f of x and which one will be equal the g prime of x. And we determine which one will be the f of x and the g prime of x using the eyelid rule. The first one which will appear on the eyelid will be our f of x. So we have our eyelid where the I stands for the inverse trigonometric function, and the L stands for the logarithmic function, and the A stands for algebraic function, and the T stands for trigonometric function, and the E stands for exponential function. On our integral, the x is an algebraic function represented by the letter A. So that letter A represents the x, and the e raised to the power negative 2x is an exponential function represented by the letter E. So we have that letter E, and as we can see, the A comes before the E. So the A, the algebraic function, will be our f of x. So our f of x is equal to x, and the g prime of x will be equal to the e raised to the power negative 2x. The formula for integration by parts has f prime of x, the derivative of the f of x. So we have to differentiate the f of x so that we can get the f prime of x. And the formula for integration by parts has the g of x. In order for us to get that g of x, we have to integrate the g prime of x so that we can get the g of x. So let's start by differentiating the x. So the derivative of the x is equal to 1. So our f prime of x is equal to 1. And we integrate the e raised to the power negative 2x. The integral will be equal e raised to the power negative 2x. And we divide this by the derivative of that negative 2x. The derivative of the negative 2x is equal to negative 2. So we divide by negative 2. So now we can substitute. We have the integral from 0 to infinity of x multiplied by e raised to the power negative 2x dx, which will be equal the f of x multiplied by g of x, and our f of x is equal to that x, and our g of x is equal e raised to the power negative 2x divided by negative 2. So you have x multiplied by e raised to the power negative 2x divided by negative 2 minus the integral of g of x multiplied by f prime of x. And our g of x is the e raised to the power negative 2x divided by negative 2, and our f prime of x is equal to 1. So we have e raised to the power negative 2x divided by negative 2 multiplied by 1 multiplied by dx. Remember that our integral is from 0 to infinity. So let's simplify. We have this as equal x multiplied by e raised to the power negative 2x divided by negative 2 minus the integral. So we have that negative half multiplied by that negative will be positive. So we have positive, so we can take the 1 over 2 out of the integral. So we have 1 over 2 multiplied by the integral of e raised to the power negative 2x dx. This will be equal the x multiplied by e raised to the power negative 2x divided by negative 2 plus 1 over 2 multiplied by the integral of e raised to the power negative 2x. So our integral was from 0 to infinity. So the integral of e raised to the power negative 2x is e raised to the power negative 2x divided by the derivative of the negative 2x, which is negative 2. Our integral is from 0 up until infinity. So let's simplify. So this will be equal x multiplied by e raised to the power negative 2x divided by negative 2. We have that half multiplied by 1 divided by negative 2. So half multiplied by negative half will be equal to negative 1 divided by 4 multiplied by e raised to the power negative 2x with our limit from 0 to infinity. We simplify, and this will be equal the x, and we have that negative from the 2 in the denominator, so we have negative x divided by 2. So that e raised to the power negative 2x, we move it from the numerator to the denominator. The exponent changes sign to positive 2x minus 1 divided by 4. We move that e raised to the power negative 2x from the numerator to the denominator. The exponent changes sign to positive 2x. So we have e raised to the power 2x in the denominator with our limits from 0 to infinity. We substitute, and we are going to substitute the infinity and then interpret the results. So we have negative infinity in the place of the x divided by 2 multiplied by e raised to the power 2 multiplied by infinity minus 1 divided. So we substitute the infinity where there is x. So we have 1 over 4 multiplied by e raised to the power 2 multiplied by infinity minus, now we substitute the 0 where there is x. So we have minus into negative 0 divided by 2 multiplied by e raised to the power 2 multiplied by 0 minus 1 divided by 4 multiplied by e raised to the power 2 times 0. Remember that infinity is not a number, so we have to interpret the part which we substituted the infinity. In the numerator, that infinity is going to go to infinity at a linear rate. And in the denominator, the infinity is going to go to infinity at an exponential rate. So what we have in the denominator will become relatively larger than what we have in the numerator. And this whole thing will approach 0. Minus 1 divided by 4 multiplied by e to the power 2 times infinity. So that denominator will become a very big number because of the infinity. So suppose that we have 1 divided by 10. This is equal to 0.1. And if we had 1 divided by a million, this will be equal 0.0000001. So the bigger the number in the denominator, the more this approaches 0. So even that, since it's approaching infinity, it will approach 0. Minus, so 0 divided by any number will become 0. So that part will be cancelled. And we have negative 1 divided by 4. We also have the e raised to the power 2 times 0. 2 times 0 is 0, and e raised to the power 0 is equals to 1. And 1 multiplied by the 4 will be 4. So we have negative 1 over 4 multiplied by that negative, which will be equal to positive 1 divided by 4. This will then be our answer. Question 5.2, the points of intersection and the area bounded by the curves y is equals to 6x minus x squared and y is equals to x squared minus 6x plus 9 are given in the graph below. 5.2.1, we calculate the magnitude of the area bounded by the two curves. The y is equals to 6x minus x squared is that graph which is concave down. And to calculate the area, we use our formula sheet. We have two graphs which made the y the subject of the formula. So we use that formula. So we have the area equal the integral from the point A up until the point B of y1 minus y2 dx. We substitute and our area will be equal the integral from point A. So the point A will be where the area starts, the 0.879, and the point B will be where the area ends, the 5.121. So that's our A and that's our B. In the place of the A, we have 0.879, and our B is 5.121. And our y1 is the function which is on top of the other where our area is. So our y1 is the 6x minus x squared minus our y2, the function which is below where the area is, the x squared minus 6x plus 9. So in the place of the y2, we are going to substitute the x squared minus 6x plus 9 dx. Our area will be equal the integral from 0.879 up until 5.121 of 6x minus x squared, we distribute that negative inside the parentheses, so we end up with negative x squared plus 6x minus 9 dx. Our area will be equal the integral from 0,879 up until 5,121. So the 6x plus the 6x will be equal to 12x, and the negative x squared minus x squared will be equal to negative 2x squared. So you have negative 2x squared plus 12x minus 9 dx. So now we can integrate. So our area will be equal the integral of negative 2x squared, which will be equal negative 2 multiplied by x raised to the power 2. We add 1 to the exponent of the x. We take that exponent of the x, we divide with it. So we divide with that 2 plus 1 plus the integral of 12x, which will be equal to 12 multiplied by x raised to the power. We have 1 there, and we just add 1 to the exponent. We take the x plus 1, we divide through with it. So we divide by that 1 plus 1. The integral of negative 9 will be equal to negative 9x. We have our bounds from 5,121 to 0,879. And our area will be equal negative 2 multiplied by x raised to the power 2 plus 1. 2 plus 1 is equal to 3. Even in the denominator, we have 3 plus, so that 1 plus 1 is equal to 2. So we have the 12 divided by the 2, which is equal to 6 multiplied by x raised to the power 2 minus 9x. And we still have our bounds, which we are to substitute now. We have the 5,121 and the 0,879. We start by substituting the Beer number. So we have the area, which will be equal. So we are going to substitute the 5,121 where there is x. So we have negative 2 divided by 3 multiplied by 5,121 raised to the power 3 plus 6 multiplied by 5,121 in the place of the x squared minus 9 multiplied by 5,121 in the place of the x minus, so now we substitute the 0,879 where there is x. We have the negative 2 divided by 3 into 0,879 raised to the power 3 plus 6 multiplied by 0,879 in the place of the x and this will be squared minus 9 multiplied by 0,879. Our A will be equal, we start with the part which has 5,121, and then we determine also the part which has 0,879. The first part will be equals to 21,728 minus negative 3,728. Sorry, that part was supposed to be 8, not 9. Our area will be equal, so the negative multiplied by that negative will be positive, so 21,728 plus 3,728 is equal to 25,456. Area is measured in unit square. So this will be our answer. Question 5.2.2, we calculate the volume of the solid of revolution formed when the area in question 5.2.1 is rotated about the x-axis. We also use our formula sheet, and we have the volume formulas, and the one that we are going to use is that one which has two y's, and the volume will be equal pi multiplied by the integral from the point A up until point B of y1 squared minus y2 squared dx. The y1 is the function which is on top of the other, and in this case the function which is on top of the other is the 6x minus x squared. So the y1 will be our 6x minus x squared, and the y2 is the function which is beneath where the area is. So we can see that inside the formula the y1 and the y2 are squared. So let's determine the y1 squared and the y2 squared. So y1 squared will be equal 6x minus x squared squared, and this will be equal 6x minus x squared multiplied by 6x minus x squared. Our y1 squared will be equal, so we distribute the 6x into the other parentheses. So 6x multiplied by 6x will be equal 36x squared. 6x multiplied by negative x squared will be negative 6x cubed. And now we distribute the negative x squared inside the other parentheses. Negative x squared multiplied by 6x will be equal negative 6x cubed. Negative x squared multiplied by negative x squared is positive x to the power 4. y1 squared will be equal x to the power 4, and the negative 6x cubed minus 6x cubed will be equal negative 12x cubed plus the 36x squared. Now we determine the y2 squared. So the y2 squared will be equal the x squared minus 6x plus 9 raised to the power 2, which will be equal to the x squared minus 6x plus 9 multiplied by the x squared minus 6x plus 9. We start off by distributing. We start by distributing that x squared. So x squared multiplied by x squared will be equal to x to the power 4. X squared multiplied by negative 6x is negative 6x cubed. And x squared multiplied by 9 will be equal to positive 9x squared. We now distribute the negative 6x. Negative 6x multiplied by x squared will be equal to negative 6x cubed. Negative 6x multiplied by negative 6x is equal positive 36x squared. Negative 6x multiplied by 9 will be equal to negative 54x. We now distribute the positive 9. 9 multiplied by x squared is equal to positive 9x squared. 9 multiplied by negative 6x is equal to negative 54x. 9 times 9 is equal to 81. So our y2 squared will be equal x to the power 4, and the negative 6x cubed minus 6x cubed will be equal to negative 12x cubed. The 9x squared plus the 36x squared plus the 9x squared will be equal to positive 54x squared. Negative 54x minus 54x is equal negative 108x plus the remaining 81. So now we have y2 squared. We substitute into our formula. V will be equal the integral from a to b, and our a, where the area starts, is 0,879 and our b is 5,121. So we have the 0,879 and the 5,121. And we have the y1. The y1 squared is equal x to the power 4 minus 12x cubed plus 36x squared. So x to the power 4 minus 12x cubed plus 36x squared, and we minus this with the y2 squared, which is that. So we have the y2 squared as equal x to the power 4 minus 12x cubed plus 54x squared minus 108x plus 81. And we have our dx. So our v, so we were supposed to have the pi, so sorry about that. So we have our pi, and our v will be equal pi multiplied by the integral from 0,879 to 5,121 of x to the power 4 minus 12x cubed plus 36x squared. We distribute that the negative inside the parentheses and we have negative x to the power 4 plus 12x cubed minus 54x squared plus 108x minus 81 dx. We simplify and v will be equal pi multiplied by the integral from 0,879 up until 5,121, and that x to the power 4 minus that x to the power 4 will be 0, and negative 12x cubed, and that positive 12x cubed will cancel out, and 36x squared minus 54x squared will be equals to 18x squared. So a negative 18x squared, and we have the positive 108x and the minus 81 dx. So now let's integrate. So our v will be equal pi, and we have negative 18 multiplied by the integral of x squared, which is x to the power 2. We add 1 to the exponent of the x. We divide by the 2 plus 1 in the exponent. So this will be divided by the 2 plus 1 plus 108 multiplied by the integral of the x, which will be the x. Remember, the x has an exponent of 1, and we add 1 to the exponent of the x, and we divide by the exponent of the x, the 1 plus 1 minus the integral of 81, which is 81x, with our bounds as 0,879 and 5,121. Our v will be equal pi into negative, so that 2 plus 1 is equals to 3, and the 1 plus 1 is equals to 2. So 18 divided by 3 is equals to 6 multiplied by x to the power 3 plus 108 divided by that 1 plus 1, which is 2, will be equals to 54 multiplied by x to the power 2 minus 81x. We have our boundaries as 5,121 and 0,879. Now we substitute. We start with the bigger number, so our v will be equal pi into minus, so we substitute that 5,121. So we have minus 6 into 5,121 raised to the power 3 plus 54 multiplied by 5,121 raised to the power 2 minus 81 multiplied by 5,121 minus, we substitute the 0,879 where there is x. So we have minus 6 multiplied by 0,879 raised to the power 3 plus 54 multiplied by 0.879 raised to the power 2 minus 81 multiplied by 0.879. V will be equal pi into so we start by calculating that side first, and we will minus it from that side. So the part with 5,121 is equal 195,55, and the part where we substituted 0.879 is equal negative 33,55, and our V will be equal 719,739 unit cube, and this will be our answer. Question 5.3, we calculate the second moment of area of a rectangular lamina with sides 9 centimeters and 4 centimeters about the longer side, and about the longer side being our keyword. From our formula sheet, we have the following, and our second moment of area, denoted by the letter I, is equal the integral from the point A up until the point B of r squared multiplied by dA, and it's a second moment of area because the r is raised to the power 2. For the first moment of area, the r will be raised to the power 1. For now, let's determine the dA, also called the area element. We have two scenarios. Either the longer side will be vertical, or the longer side will be horizontal. We can have the vertical as equal 9 centimeters and the horizontal as equal 4 centimeters, or have the horizontal as equal 9 centimeters and the vertical is equal 4 centimeters. So we can have y is equal to 4 and x is equal to 9, or x is equal to 4 or y is equal 9. So if we were to go with the blue rectangular prism, our area will be equal x multiplied by y. And since we were told that we calculate the moment about the longer side will be constant. So in the place of the longer side, which in this case is y, we substitute the 9. So we have a is equal to x multiplied by 9, and we differentiate the area with respect to x. So the derivative of the area with respect to the derivative of x will be equal the derivative of the x, which is equal to 1 multiplied by the 9. 1 multiplied by 9 is equal 9. We multiply both sides of the equation by the dx, and on the left hand side, the dx and the dx will cancel out, such that dA, the area element, will be equal 9 multiplied by dx. We copy and paste our formula But before that, if we chose the longest side as being horizontal, if we chose the red area, then the area element was going to be equal 9 multiplied by dy, and we were going to integrate with respect to y and not x, and we'll still get the same answer. So we copy and paste our formula, and the second moment of area I will be equal the integral of r squared, but in this case our r will be equal the shorter side. So our r will be equal x, and our a of the integral was gonna start at 0 and it will end at 4. So we were given the other side as equal to 4 and not 6, like the way the memorandum has claimed. So we are working with 4 and not 6. So in the place of the b, we substitute 4 and not 6. And in the place of the r, we substitute x, and it will be raised to the power 2. Our area element we already determined as equal 9 multiplied by dx. Our I will be equal, we can take that 9 out of the integral because it won't affect the integration process. Now we can integrate, and our I will be equal 9 multiplied by the integral of x squared, which will be x squared, but we add 1 to the exponent of the x, and we divide by the exponent, the new exponent, the 2 plus 1, and we have our bounds as equal 0 to 4. Our I, so we simplify, so our I will be equal 9 multiplied by x raised to the power 2 plus 1 is 3. Even in the denominator we have 3. We still have our boundaries, the 4 and the 0. Our I will be equal 9 divided by 3, which is equal 3 multiplied by x cubed with our boundaries, the 4 and the 0. Now we substitute, and we substitute the bigger number first. So in the place of the x, we are going to substitute the 4. It will be raised to the power 3 minus, now we substitute the 0 in the place of the x. It will also be raised to the power 3. And our I will be equal 192. Since we multiplied area with the second moment, we are going to have this as centimeter to the power 4. And this will be our answer for question 5.3. Thank you guys for watching. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like, and share the channel if you find this content useful.